Hello everyone, welcome back to my workbench up here in the study at Donget's Model Railway. A while ago I picked up some used hand-built points. The price was low enough that even if they turned out to be scenery to dress an engineer's yard with, I'd still have been happy with my purchase. I was hoping that I could get more out of them than that though. I've never worked with hand-built points before, so this was a bit of a risk. However, most of them are like this. While it looks a bit scrappy, it's all cosmetic or electrical damage. The tie bar works mechanically, even if the original power switching doesn't. Wheels run smoothly through both sides. It's mostly damaged or missing timbers, and they all need a rewire. Two of them are not looking so good. There's mechanical damage to the tie bar. As you can see, one side of the blades is no longer attached to the tie bar. These points are soldered construction, mostly using PCB timbers. I've done plenty of work with PCB before building electronics for the layout. So, how hard can it be? Can I replace the broken, damaged or missing timbers with new PCB timbers and have the points still work afterwards? I could get PCB point timbers cut to size and etched via channel sponsor PCBWay's PCB manufacturing service. By adding cuts to a Gerber file, I could design a PCB which contained a number of appropriately sized point timbers in a fret, ready to break out as needed. The PCB could be designed with copper pads for each rail and PCB traces connecting the pads where electrical connections are wanted between rails. I could add PCB vias, which are connections between the top and bottom surface of a PCB, to allow the wiring to be connected to the underside of the timbers. This would allow for some truly invisible wiring, entirely buried underneath the ballast. Assuming all the required timbers pack into a 100mm by 100mm square, the delivered cost for 10 sets of timbers would be around $12 US delivered to Britain and using one of the 3 different price-conscious shipping options PCBWay offers. More rapid delivery services cost a lot more, and shipping to other countries will also vary. Such a PCB would have to be designed for specific point geometry, as the timbers required for different point geometries are different. That's one of the great things about a service like this. You can have exactly what you need made, rather than be stuck with what somebody else wanted to design. It doesn't make sense for me to order a full set of PCB timbers for repairing the existing points. With repairs, I only need a few timbers per point. There's a high likelihood of it being the same timbers over and over again, and I'm pretty sure I've got 4 different designs in here, not including the single slip and the 2 curved diamonds. But if, who am I kidding, when this evolves into me building my own points from scratch, having these produced will be a great option, and in the right quantity cheaper than buying PCB strip to make a set of points. It will be particularly relevant if I start building with flat bottom rail, as while bullhead points are relatively well supported commercially already, there's barely any existing commercial provision for flat bottom rail. As I said though, I don't need a full set of timbers for each point. I've got some random ones to replace, and I haven't even surveyed to find out exactly which ones I need yet, and I'm not entirely sure what the design parameters of these points even are. So instead, I have some long PCB point timbering strips right here, and I'm going to cut them to length as needed to replace the broken and missing timbers. I'm not doing any careful measuring here, I'm cutting them roughly to length comparing to the other timbers. I'm also spacing them by eye. This is intended to represent point work which is old and may have been repaired on site. This point work will either be in my engineer's yard, or when used on the main line, representing point work due for replacement. Unexpectedly, my new point timbering appears to be wider than the previous timbers I'm replacing. In real life, point timbers are wider than normal sleepers used on plain track. This is done so that the chairs can be secured at an angle for the diverging track. Obviously that's not necessary on plain line where the sleepers can stay perpendicular to the track at all times. It looks like what's happened here is these points were built originally with narrower sleeper strip intended for plain line, not for points. Perhaps they were representing a prototype location where that had been done, or perhaps they just made a mistake. Either way, that's okay. It now looks like this point is ancient and someone's been round and fixed a few rotten timbers, and it's now got a mixture of standards in it. I also expect the difference to be significantly less noticeable when they're painted and embedded in what passes for ballast in an engineer's yard. I'm filing a slot through the copper on the PCB so that there is no short between the left and right rail. While this soldered joint is being done primarily for mechanical purposes, it is important to remember this is also an electrical joint. If I miss one of these, there will be a short on the track from left rail to right rail. There is the remains of a power feed from the tie bar to the frog, visibly running along the top of the timbers. This is a basic way of switching the frog polarity with the movement of the tie bar. It's kind of ugly for it to appear on top of the point, so I will be removing it and relying on the switches on my point motor rather than using this. Given the amount of paint in these contacts, I also don't trust them. Many of these are already a bit broken, probably don't work properly. I do need to add droppers to power these. On a Pico point with plastic timbers, I attach a wire to each side underneath, creating a bridge between the stock rail and the blade in the process. These points won't need that as the solder joints on the PCB timbers already create this bridge, so just attaching to the stock rail is sufficient. I'm also attaching a dropper to the frog. Again, further continuity will be provided by the timbering, so just attaching it to one convenient location is sufficient. I don't need to jumper it across several rails. If you are enjoying this video, or finding it useful, hit the like button. If you want to see more of my layout or the stuff I run on it, hit the subscribe button. If you have a question, comment or suggestion, write it in the comment section below. I've got a few of these to get through, so I'm going to crack this next one out. It will go faster than the first one. Knowing what you're doing always makes things faster. In the points I've looked at so far, the blades are electrically connected to the stock rails via the PCB timbers. There is a crude switch at the tie bar which connects to one or other stock rail. There is a thin metal tongue attached to the tie bar. It sits above the sleeper before the tie bar, sliding underneath a couple of thin metal contacts soldered to it, one on each side. This is then wired to the frog via a wire running up the centre of the top surface of the point. The frog is electrically separate from the rest of the point. In this point, these rails are continuous. The frog is not separated from the blades. This will mean the far blade is the opposite polarity to the adjacent stock rail. That's a problem. If the wheels were to contact the blade as they go past this point, there will be a short circuit. I don't like that possibility, so while I'm working on these, I'm going to convert any I find like this to operate the same as the others. To separate the frog from the blades, I'll need to cut these two inner rails. I need to do so after the point they finish bending. I need the blades to be attached to a minimum of 2 timbers before I make the cut. This point is not made with PCB timbers. It has riveted timbers instead. On the plus side, this does make where the blade is attached to the timbers really clear. Rivets haven't been fitted where the blades move. On the minus side, there is no automatic electrical connection like there is with the PCB point, where the blades are electrically connected to the stock rails via the PCB. I may choose to replace a couple of the timbers to achieve that electrical connection, or I could bridge the rails with droppers like I do on Pico points. This is the problem gap. If the back of the wheel touches the blade while going through here, that's what causes the short and what needs fixing. These are the 2 points with broken tie bars. Let's see if I can reattach them. This is a bit tricky as I need to solder the blade back to the tie bar without accidentally attaching the blade to the stock rail, or the tie bar to the stock rail, or the blade to the adjacent point timber, all of which could easily happen if the solder wicks somewhere I'm not expecting. I need the solder joint to be on the inside of the blade only, so that the tie bar will run smoothly underneath the stock rail and allow the blade to close properly. I'm spacing the blade away from the stock rail while I make the joint so I can see if any solder wicks underneath towards the stock rail. The joint on the inside also needs to stay low enough so that there is no chance of being caught by a passing wheel flange. That seems to have worked. I don't know how reliable this is going to be, how long this joint will hold for, but it does seem to have worked. The second point with a disconnected blade is going to be more challenging to repair. It's a tighter curve, and there are a lot of broken timbers too, including both sides of the tie bar. It's also one of the ones with no break in the rails between the blades and the V. Okay, that's the blades reattached. I've now got many timbers to replace. Detaching the riveted ones isn't much different of a process to detaching the PCB ones. I'm going to replace them with PCB timbers though, not try and recreate the riveted board construction. This will also allow me to make the electrical connections that PCB timbers allow. Actually, hang on a second. No, this is going to be the other side of the brake, which means there, and then cut those two. Right. I need to cut the rails to separate the V from the blades. I don't have a small enough cut-off wheel that I can make a vertical cut in just the inside two rails with, so I'm going to use this saw that I can detach the blade from. It allows me to thread the blade through the point and cut just the middle two rails without hitting the outer ones. Here's the repaired point. You can see where the breaks have been made in the PCB timbers to create the electrically separate sections, and how that interacts with the cuts in the rails. The last task is to check for continuity between the rails that should have it, and for no continuity between the rails that shouldn't. That's an unexpected result. That's interesting to learn. The two originally PCB timbered points are fine, but there's a hard short between the left and right rails on the rivet constructed point with the repaired tie bar. The riveted timbers won't conduct, and I can't see an error in the PCB timbers I added. All of those are slotted correctly. I suspect the tie bar. Remember, originally this was not wired properly. It had both blades electrically connected at the frog end. There would have been no reason not to electrically connect the blades at the blade end either. The tie bar does not have rivets through it, so it's not the same construction as the rest of the point. If it's a bit of PCB and has not been gapped, that would explain the electrical connection. I'll file a slot in it to break that connection. Well, I've been filing away at this off camera, and I've made quite a groove and not got to the bottom of the copper yet. I think I was wrong. I think this tie bar is not a piece of PCB. I think it's a solid piece of copper. Obviously that's no good for what I want, so let's create a new one from PCB and solder it in place. I'm going to file away the copper on both ends and in the middle to help prevent any stray solder from getting on the wrong side of the blade. Let's have a look at that old tie bar now and see what we think it actually is. Yeah, that's coming up copper on all sides. I think that is a solid piece of copper. This point tests good now. All I need to do now is drill a few tiny holes in the tie bar and finish the rest of the points. Then I can lay them. And then I'll be able to drive around the room on the scenic level. See you next time up here in the study at Donget's Model Railway.